So this is a test. Okay, good. I think our microphone's working now. So this is a reconstruction of the video that we were looking at here in 8.1. And so this is where we stopped, I believe. This is the power co problem. And before we get into the examples, I just wanted to talk about how you might translate this problem into a transshipment problem. It sure looks like a transshipment problem. The only thing that's different about this problem than the transshipment problem is that we don't have a supply and a demand. However, we do have the supply point and we do have the demand point. And so one way to think about this is that we can just use a supply of 1 and a demand of 1. And then that way, as we're shipping this 1 unit through the system, it will track our cost. And then we'll try to find the minimum cost. Okay, so with that, remember the rest of these cells are going to be our transshipment points. And so, therefore, they will have S being 1, right? And so, therefore, we can go ahead and write down our tableau here. For our supply, we'll have 1, 2, 3, 4, 5. 1 is not going to be demand, so that's 2, 3, 4, 5, 6. And so the 2, 3, 4, 5 are the transshipment points. 1 is supply and 6 is demand. Good. And now we just write down our costs. So for example, 1 to 2 is 4. 1 to 3 is 3. 1 to 4 is, we're going to use M for when things are not connected. Then we'll have a supply of 1. Good. For 2, we're going from 2 to 4, which will be 3, and then 2 to 5, which is 2. Everything else is M. Oops, except for that one. 2 to 2 is just going to be 0 cost. So we can ship stuff to ourselves. And then for node 3, we have something similar. The only thing that 3 is going to is 5 at a price of 3, and then we'll have a 0 there, and M's everywhere. Ooh, not there. Good. And then similarly for 4, 4 is only connected to 6 with a cost of 2. And then 4 can be connected to 4, and then we have M's everywhere else. Similarly, for 5, 5 is only connected to 6 by a cost of 2. 5 can be connected to 5, and then M's everywhere else with supplies of 1. Good. And so I think you see how this is going to work. Whoops. These have 1s down here. Good. And now we have a transportation tableau. Transportation tableau. And so if you were to actually solve this problem, the shortest path problem, using a spreadsheet, it's probably worthwhile just to go ahead and translate it, into a transshipment problem, because this would be easier to code up on your, it's more straightforward to set up in your spreadsheet. Good. All right. So we can translate these shortest path problems into a transshipment problem. All right. Now, the second thing I wanted to talk about in this video is just how to set up kind of a weird situation into a graph. Whoops, sorry about that. And that is, I've got some shelving units. Shelving units for a library. And I have 200 books that are 4 inches tall. 100 books that are 8 inches tall, and 80 books 12 inches tall. Okay, and now as I'm building my bookshelf, there's some costs associated with that. I'm going to assume, by the way, that each is 1/2 inch thick. so I get some width going on there. Okay, so there's a fixed cost for each shelf, $2,300 per shelf. Okay, and there's an area cost of $5 per square inch. So that's $5, and then the square inches are, remember, we have, our books are 1/2 inch thick, so that's going to be thickness, or sorry, the height, which would be 4, 8, or 12 times 1/2. Okay, and that's per book. Per book. Yeah. So let's do an example maybe. So how much would it cost to store all books using 12-inch shelving? All books with 12-inch shelving. Well, that would be our 2,300 plus, how many books do we have? 380 times, right, that's the number of books, and then our area here is going to be 5 times, the height is 12, and our thickness is 1/2. Good. If you compute that, that becomes 13,700. So that'll be a number we want to try to remember. Okay, so now let's think about how we might, what are some other options for shelving the books? Okay, well, before we go into that, I think it's probably worthwhile to define some notation that will come in handy. And so, by the way, this is not obvious notation, so this would be given to you probably as a hint. So we'll let Cij be the cost of shelving books that are greater than I, greater than I in height and less than or equal to j. So what do we mean by that? So for example, 04 would be only 4-inch books. C, we'll go ahead and compute that in just a second. How about 08 then? That would be 4-inch plus 8-inch books, right? And then C012 would be all the books, 4 inches plus 8 inches plus 12 inches. Good. And actually, that's what we already computed, right? So this is going to be 13,700. So let's go back and see if we can compute these other ones. For the 4-inch books, we're going to have our 2,300 plus, how many 4-inch books do we have? We have 200 of them. So that's going to be 200 times, then our 5 times 4 times 1/2. Good. So that's going to end up being 4,300. Okay, so 4-inch plus 8-inch books. This is, by the way, when we talk about 4-inch and 8-inch books, these are using 8-inch shelving. And so it's going to be 2,300 plus, and then we're going to have both 4-inch and 8-inch books. 4-inch and 8-inch books, that's 300 books. Okay, 300 times 5 times 8 times 1/2. Okay, and if you compute that, that turns out to be 8,300. Okay, so similarly, what are some other values? There we go. How about C48? What would that be? Well, C48 is the cost of shelving books that are bigger than 4, less than or equal to 8. So that's only 8-inch books, right? And so for that, we'll have 2,300 plus 100 times or $5 times our 8 inches times 1/2. Good. And so that number is 4,300. And I will let you think about these other ones. It's 412 is going to be 7,700. And C 812 will be 4,700. Okay, so I have all these costs for my C's. And so now, how is this going to be related to a network? Well, the idea is our network is going to be our inches for our books are going to be the nodes. So 0, 4, and then we'll have an 8 and a 12. And so this edge right here will be for C04, which was 4,300. So the cost for that is 4,300. Right, and then 412. So that one's 7,700. Right, and then 812 was 4,700. 0 to 8 is here 8,300. Are we missing anything? How about 012? That's going to be what was 012? That was all the books, right? 13,700. And then we also have one just on the 4/8, right? And that's going to be 4,300. Good. And so now we have our new diagram here. And so the idea is you want to go from 0 to 12 as cheaply as possible. And that will tell you how to shelve your books. Isn't that amazing? I will stop here. I think I will do one more example after this, talking about the machinery problem. So look forward to that in the next video.